In this problem, we are mixing two solutions together. So anytime you mix two solutions together, you have to do a dilution. So we have copper chloride. We have 100 milliliters of it in a 0.01 molar solution. And we have sodium phosphate. We have 200 milliliters of it in a 0.02 molar solution. So we have a total of 300 milliliters. So we use M1V1 equals M2V2 to do the dilution. Alright, so for the copper chloride, we have 0.01 times 100. We're solving for M2, and our new volume is 300. Therefore, our new concentration, or our diluted concentration, is 0.00333 molar. For the sodium phosphate, we have 0.02 times 200 equal to its new concentration times a total of 300 milliliters, which gives us a concentration of 0.0133 molar. Alright, so now we know the concentrations. When we mix these two solutions together, the copper chloride plus the sodium phosphate, the possible compounds are copper phosphate and sodium chloride. Sodium chloride will not be a precipitate, but this might be a precipitate, the copper phosphate. So let's check. We have the KSP value, so we need to find Q. Copper phosphate in equilibrium with copper 2 plus, 3 of those, plus 2 phosphates, and KSP or Q, both really, are equal to copper 2 plus cubed times phosphate squared. Alright, so what concentration do we have? For the copper, we have a concentration of 0.00333. And for this one, we have a concentration of 0.0133. Alright, so we plug those numbers in. And you're probably wondering why I'm not multiplying by 3 or by 2 for each of these values. It's because we're not looking at this breaking apart. We're looking at the concentrations we already have. So there's only one phosphate from this group and only one chloride from this group. So that's where I get these concentrations. We're trying to see if this will precipitate by finding Q. So we plug in the concentrations that we have. And I get that Q is equal to 6.53 times 10 to the negative 12. Well, compared to KSP, this is much greater than KSP. Therefore, it should precipitate.